Hello, my esteemed viewers. You are welcome to this channel. And in this lesson, we're going to look at alternative to chemistry practicals. And that has to do with your salt analysis as well as titration. In this video, we will be paying very close attention to the salt analysis. And that has to do with identifying the ions that are present in a PV salt sample. Look at this simple statement. The following test was conducted on the substance X. Fill in the blank spaces and name X. Of course, in your external exams like GCE, you will not be performing the experiment in reality. So they would have done the experiment and then prepare a table for you. Based on the knowledge you already have, you will be expected to complete the table or fill in the blank spaces. I encourage you to watch this video to the end, because at the end of this video, we are going to have a short drill. I will not explain what the short drill is now until you get to the end of the video. You will see that what the drill is all about. Now, let us pay a very close attention to the test that was done on substance X. And let's see if we will be able to fill up the spaces that is expected of us. Now look at the experiment that has been done for us. Now we have the test. As you can see, we have the test, we have the observation, and of course we have the inference. This is how the table for salt analysis normally look like. We have the test, we have the observation, as well as the inference. Now let's run through the table first, then before we come back and answer the questions that we are given. Now we have substance S mixed with water. Under the observation, it was left blank, and under the inference, we were told that copper 2 ion and iron 2 ion are present. So in this case, what will you do? How will you handle this type of situation? What do you think will be under observation? Well, while you are thinking, let's take the next step. Now, obviously, the solution of S would have been splitted up into 2 or more parts. Then the first part of the solution, X, was mixed with aqueous sodium hydroxide. Obviously, it drops. Then under observation, we were told that a blue gelatinous precipitate was observed. In that case, what do you think will be under the inference? That space again was left for you blank to fill up. Then we were told again that sodium hydroxide now reacted with substance S, this time in excess. The observation was left for us, but under the inference, we were told that copper 2 ion was confirmed. Now, knowing that copper 2 ion has been confirmed, it is expected that you know what will be the observation if you have sodium hydroxide reacting with substance S in excess. Then the later part or the later portion of substance X now reacted with barium chloride in drops. And you recall that in this state, you acidify the solution with dilute HCl. All right. The function of the dilute HCl is to prevent the precipitation of other ions. I didn't bother writing the HCl here. Now, under the observation, we were told that white precipitate was formed. Then, what will be your inference? Well, be thinking about that. And again, solution X reacted with or mixed with barium chloride in excess of HCl. We were told that the other observation, we were told to fill up the space, having confirmed SO42 ion. Now, this is usually how the exam looks like. This is how the exam looks like. Now, having had a general overview, let us now go back and start the experiment again, the test, and see how we fill up the blank spaces. Now, look at the first one, solution X mixed with water. Now, when a solid is mixed with water, there are so many things that should come to your mind. Sometimes you will watch out for solubility, but in this case, they are not checking you on solubility. So long as they said copper 2 ion and iron 2 ion are present, it means they are not asking for solubility. Now, what is the color of copper 2 ion and iron 2 ion in solution? Very simple. That is what will be under your observation. Somebody can write light blue solution. Another can put light green, because these two ions can either be blue or green. And for me, I will go for blue. So I will just come here, I will put blue solution. That means the solution will be blue. That is what you will observe. Then the next stage, solution X plus sodium hydroxide. We were told blue gelatinous precipitate. You recall that when a precipitate is gelatinous, it means it's something oily. This word gelatinous comes from jelly. So it's something oily, not really mixing up well. So if sodium hydroxide gives blue gelatinous precipitate, right, with solution X, what will you say here? Obviously, this is no longer iron 2. So you just come here and put copper 2 ion. Copper 2 is present. Copper 2 is present. You put it there. Fine. Then the next stage, we were told that solution X reacted with sodium hydroxide, this time in excess. So when the solution now is in excess, then copper 2 ions now confirm. You will also have the same blue, or you can even put deep blue. Deep blue precipitate. I'm using PPT to represent a precipitate. The precipitate is also gelatinous, so you can include that deep blue gelatinous precipitate. This is the only condition under which you confirm copper 2 ion. Then let's move on. In the next step, we were told that X solution, the other solution now, we said that after mixing, forming a solution of X with water, you split it up into two. While you use the first part to test for the cation, the second part now, we want to use it to test for the anion. We were told that solution S plus barium chloride, and then acidified with HCl. Under observation, we were told white precipitate was observed. Obviously, barium chloride is used to test for the presence or absence of sulfate and sulfite. So under your observation here, it will not be wrong if you write SO4 2 minus and SO3 2 minus present. These are the only two ions that can give white precipitate with barium chloride. So long as this white precipitate was formed, it means these two ions, one of them is present. Now look at the next one. Solution of S with barium chloride, HCl in excess. We were told that SO42 ion is now confirmed. So what will be your observation? Again, you will still have your white precipitate. You put the white precipitate there. this time insoluble, because the white precipitate formed for SO42 ion is not soluble in excess of barium chloride or excess of HCl. So in that case, we've been able to fill in the blank spaces. So it's all about sense. It's all about applying common knowledge you have acquired from the test you've done so far. Now, having identified the cation as copper 2 ion, and you've identified the anion as the sulfate, then you can now name substance X. Obviously, substance S is what? Copper 2 tetraoxosulphate, CC. So you say this alternative to practical is actually very interesting, and it requires a little degree of thinking, ability to harmonize and put in order all the things that you have studied. Now this time, let's look at the special drill. Let's go there and see the drill. Let's see what the drill is all about. Yeah, exactly. We have the quick drill. Now, what do we have under this quick drill? Just look up. We have again the test, the observation, as well as the inference. Now, number one, we were told that solution A, are you saying it? The solution A was dropped on the cube of sugar. You know, cube of sugar is white and is solid. Substance A or liquid A or solution A was added to cube of sugar. Under observation, we were told that the white cube of sugar turns black. Can you infer or can you tell what is A? That is the drill. Let's go on. Look at number 2. Gas B, right, was mixed with ammonia gas. Under the inference, we were told that we have a dense white fumes were formed. Gas B reacted with or mixed with ammonia gas. Dense white fumes were formed. Can you tell what is B? What is gas B? What do you think gas B is? Number 3. Substance K is solid and is white, and few drops of water were poured on it. Okay? Under observation, we were told that substance A that was white when solid turns blue. Can you therefore conclude or tell what is K? Think about it. Now, this number 4 is actually the main drill. We have 4 solutions: C, D, E, and F. These 4 solutions were mixed up. The 4 solutions were mixed, and then the test tube where the 4 solutions were mixed was slanted. Under the observation, we were told that a brown ring was formed. With this information, brown ring, can you tell what is solution C, D, E, and F? Or can you even tell what is the anion that we are actually checking for here? Fine. Let me watch and hear from you. Now, let's go to number 5. Number 5, we're told that gas H was exposed to lighted splinter, or a lighted splinter was brought close to gas H. Under observation, a pop sound was heard. Can you tell what is H? Now look at number 6. We were told that gas I was brought in contact with a glowing splinter, and the glowing splinter was rekindled. Can you tell what is I? Now look at this other gas mixture. We were told that a gas jar H was opened, right? The gas jar was opened. Then another observation, rotten egg smell was perceived. With this information, can you name the gas that was in the jar? Very interesting. And finally, gas L was mixed with lime water. or directed into lime water. Under observation, we were told that the lime water turns milky. Can you therefore suggest what gas L is? Or for further information, if you continue bubbling the gas into the lime water, the milkiness will disappear and reappear again and disappear. So just understand that this gas with lime water, yes, it will turn milky. If you keep bubbling the gas into lime water, the milkiness will disappear and the solution become clear. Therefore, what do you think is gas L? Yes, this is the quick drill that I have for you. If you have the solution, drop it in the comment section of this video. I will check it and then I will upload the solution to the quick drill tomorrow. Fine. If you find this video very interesting, thank you, and we ask you to quick subscribe to this channel, because it's a one special channel that will be addressing our needs. Subscribe, turn on the notification bell so that whenever I upload new video, you'll be among the first to observe or get the video. Recommend this channel to your friends who you think will be needing the channel. And for our returning viewer, thank you very much for believing in us. And if you are seeing this video for the first time, please do all the honor and favor, subscribe to this channel, turn on the notification bell so that whenever I upload a new video, you'll be among the first to watch it. Thank you very much for watching this video. See you in my next video. Bye.